Welcome back. Today we're going to begin Chapter 7. We only have 2 days left in the semester to look at these concepts in Chapter 7, so we're going to just take a brief look at trigonometric identities today and then some trig equations next class, and that'll wrap up the semester for us. So to get started today, I wanted to kind of emphasize the difference between an equation and an identity. So an equation is a statement that two mathematical expressions are equal. And so what we can do is we can solve these equations and get solutions. So an identity is an equation, so it's a type of equation here that's true for all values of the variables. Okay, so when we look at these last two, these two are going to be true for everything that we put in for x and everything that we put in for t. They're going to be true. This one is not going to be true for everything because we know that here x could only be 3 to make that a true statement. So the difference between an identity and an equation is the identity is a type of equation that's going to be true for all values of that particular of the variable. It's going to be true for everything. Okay, so we've talked about some reciprocal identities. So knowing these is going to be very important as we look at this section here. Your Pythagorean identities, being very familiar with these three, and when they pop up in a problem, being able to recognize it's going to be helpful. And then even the even and odd identities, we're not going to do a lot with the cofunction identities. Basically, they say that if sine is shifted, if you do a horizontal shift of sine, you can make it into cosine, and a horizontal shift of tangent can become cotangent, and so forth. So that's what we're really saying with that. Okay, so basically identities are going to allow us to write that same expression in different ways. A lot of times it's possible and necessary in order to rewrite a complicated looking expression as a much simpler one. So we may start out with a really complicated one, and by substituting trig identities and simplifying, we can make it reduced down to a much simpler expression. So here are some techniques that we're going, or strategies that we're going to use today. So the first one and the most basic one is to rewrite everything in terms of sine and cosine. So if you have a tangent in your problem or you have a secant in your problem, rewrite that in terms of sine and cosine. Get everything to just those basic two functions, and that's usually helpful. Another one is if you have like two fractions, get a common denominator and combine those together, and that can be helpful. If you have what we call bunny ears, which is basically if you've got two expressions in the numerator and a single expression in the denominator, then you can break it apart and you would have like a over c plus b over c, and that can be helpful as well. And then the fourth one is substituting for known trig identity. So maybe you see sine squared plus cosine squared equal, maybe you see sine squared plus cosine squared in your problem, and you can substitute 1 for that because we know that sine squared plus cosine squared is 1. So we're going to look at examples of all of this as we go through today. The first one that we have here is that we have cosine times tangent. So we're going to use that very basic one that we just said, which is to rewrite in terms of sine and cosine. So in the place of tangent, I'm going to go back to these reciprocal identities here, and basically remember that tangent is sine over cosine. So I'm going to replace tangent with sine over cosine. That's going to allow me to cancel the cosines out and simplify that whole expression to just be sine of t. Okay, the next one here, and any time you feel like you want to try it before I do the problem, feel free to pause and check your answers. In fact, I would encourage you, once you kind of see how this works, to do that. Here in the place of cosine, we're going to again use that same technique, and we're going to replace, sorry, in the place of cosecant, not cosine. In the place of cosecant, we're going to replace that with sine or cosine. So we know that cosecant is 1 over sine. So I'm going to replace cosecant with 1 over sine. So I'm going to have cosine over sine. And going back to those reciprocal identities, which you really need to know, cosine over sine is cotangent. So we have cosine over sine is equal to cotangent, and so cotangent would be our answer for this one. Okay, so continuing along here, again, we want to take these down to the basic sine and cosine function. So I'm going to replace secant with, secant is 1 over cosine. So I'm going to have sine over cosine, and that's going to be tangent. One thing with this is that think of this as a proof. You're proving that sine t secant t is going to simplify to be tangent of t. So it's not enough to just write down tangent of t. You have to verify this for me. So these steps are part of your answer, okay? Your answer is not just tangent of t, it's everything in between this step and this step that's going to be your answer. So make sure you're writing everything out. Okay, here we have a couple things we can replace. Tangent we can replace with sine over cosine, and cosecant we can replace with 1 over cosine, sorry, 1 over sine. Okay, these sines will cancel and we'll have 1 over cosine. 1 over cosine is secant. Okay, here we have one with these squares, tangent squared and secant squared. This is not one I would recommend making substitutions all the way back to sine and cosine. What I would suggest doing is substituting a known identity, and that known identity is going to be using the Pythagorean identity that says tangent squared plus 1 is secant squared. Okay, so you can go back and look. I'm not going to go all the way back on that slide, but on that slide and on your formula sheet, you'll see that there is a trig identity that says tangent squared plus 1 equals secant squared. So what I'm going to do is I'm going to come over here and I'm going to replace. It really doesn't matter which one I replace. If I want to replace secant squared with tangent squared plus 1, that's fine. If I want to replace tangent squared with secant squared minus 1, that's fine as well. I'm going to replace secant squared with this. So I'm going to have tangent squared minus, in the place of secant squared, I'm going to put in tangent squared plus 1. Okay, I'm going to distribute my negative sign. What I'll see is that these two are going to cancel, and I'm going to be left with negative 1. Again, if you put negative 1 as your answer and you don't show me these steps, you're not going to be getting credit for this. Okay, here we have one that we're ready to simplify. Okay, on this one, we're going to go all the way back to sine and cosine again. I will say this, it takes practice for you to recognize what you want to do with these problems. So if you try one method and it looks like it's getting more complicated instead of getting less complicated, then scratch that, start over, and try a different method, because sometimes more than one method will get you to the place you need to go. Some will be shorter, some will be longer, but it doesn't mean that your way is wrong. But if it is looking more complicated instead of less, I would say you probably need to start over and try something different. But it does take practice. You don't necessarily just automatically know what to do unless you've practiced with these a lot. So in the place of secant of x, I'm going to put in 1 over cosine of x. And in the place of cosecant, I'm going to put in 1 over sine of x. Okay, here I have two fractions that are being divided. So anytime I have two fractions being divided, I'm going to do keep, change, flip. So that's going to give me the sine of x over cosine of x. And sine over cosine is tangent. So again, all these steps are necessary to show me that that equals tangent. Okay, this one's going to involve several different techniques. So it's going to be a little bit longer than some we've been doing here. The first thing that we're going to do is we're going to replace this cotangent so that we get everything down to being from sine, to being either sine or cosine. So I'm going to have sine of u plus, this will be cosine divided by sine, and then I'm going to multiply that by cosine again. So what I see here is I have sine of u plus cosine times cosine is going to be cosine squared over sine of u. Okay, so I'm looking at cosine squared. That's getting me to thinking about the possibility of trying to use the Pythagorean identity sine squared plus cosine squared equals 1, but I don't have sine squared in my problem yet. So at this point, what we're going to do, once we've used the technique of substituting for sine and cosine, the next thing we're going to do is to actually get a common denominator. Okay, so this fraction is over sine, so we need to have this one also be over sine. So that's going to mean that I need to multiply the numerator and the denominator by sine of u in order to get sine in the denominator, because whatever I do the numerator, I have to do to the denominator here. So I'm going to have sine squared of u over sine of u plus cosine squared of u over sine of u. Once my denominators are alike, I can then combine this all together into one fraction. Okay, so in the place of sine squared plus cosine squared, if you remember, that is our Pythagorean identity. Sine squared plus cosine squared equals 1. So I'm going to have 1 over the sine of u. 1 over sine is cosecant u. So all that simplifies down to being cosecant of u. Okay, on this one, we are actually going to use our Pythagorean identity again. So we said before that secant squared is 1 plus tangent squared. So we can manipulate these around as we need to. So we could say tangent squared is secant squared minus 1 and so forth. So we just use it as we need here. But in this perfectly matches up the 1 plus tangent squared so that I can put in secant squared. So I'm going to have cosine squared times, in the place of this, I'm going to put secant squared. Okay, now I'm going to take this to cosine. So I'm going to have cosine squared times 1 over cosine squared, because that's what secant squared is 1 over cosine squared. So my cosines are going to cancel, and I'm actually going to just have 1 as my answer. Okay, this one's going to be a little bit longer and have a few more steps involved, but we will definitely get through it. If we look at this one, the first thing I'm going to do on this is I'm going to actually go in and substitute in the place of secant x. I'm going to put in 1 over cosine of x. Okay, I'm going to kind of forget about the sine for just a little bit and look at this numerator part and basically do what we just got through doing on the previous problem. I'm going to get common denominators here. So that means that this has to be multiplied by cosine of x over cosine of x. So I'm going to have 1 over cosine of x minus cosine squared over cosine x. And then all that is still over sine of x. Okay, I'm going to combine these two together. So I'll have 1 minus cosine squared x. That's over cosine of x, just combining these two with a like denominator or common denominator together. And then that's over sine of x. So I'm just kind of dragging this sine of x along for right now. I'm not really doing anything with that. If I look at this one, one thing I'm going to kind of come down here to the side. We have sine squared plus cosine squared is 1. So sine squared is 1 minus cosine squared. So in the place of this cosine, 1 minus cosine squared, I can put in sine squared. Okay, so now I have this fraction, and then here I have a fraction sine over 1. So I'm going to do keep. Okay, so keep, change it to multiplication, and then flip. Okay, when that happens, I can now cancel sine with one of these signs. And so I'm going to have sine over cosine, and that's going to be equal to tangent. Okay, looking at this one here as another example, I'm going to go in and rewrite each of these in terms of sine and cosine. So I'm going to have the cosine of x over the sine of x. And then here I'm going to have 1 over the sine of x minus the sine of x. Okay, here I'm going to work in the denominator part and kind of replicate the process that I've done the last couple examples. I'm going to get a common denominator for this part. So in doing that, what I'm going to need to do is I'm going to need to multiply this by sine of x over sine of x so that I'm not actually changing the value of it. So I'll have cosine over sine for my numerator. And then this denominator is going to be 1 over sine minus sine squared over sine. If I come back down here, I still just recopying this numerator. I'm going to combine these two into one fraction since they now have a common denominator. So they have a common denominator of sine, and then the numerator is going to be 1 minus sine squared. So I've got cosine over sine. And now that I have it into two fractions that are being divided, I'm going to do keep, change, and flip. Okay, so their signs would cancel at this point. And you may recall that 1 minus sine squared is actually cosine squared. That goes back to the Pythagorean identity. So I end up with cosine over cosine squared, which is 1 over cosine, which is secant. So this simplifies to be secant. But again, it's not just this final answer that's important, it's this whole process that's going to be important. Okay, on this one, we are going to replace tangent with sine over cosine. So that's going to give me cosine of t plus sine squared t over cosine of t. I need to combine these two fractions together. I need to get a common denominator. So that common denominator is going to be cosine. So I'll multiply the numerator and the denominator here by cosine so that the denominators will be the same. So I'm going to end up with cosine squared over cosine plus sine squared over cosine. Okay, I can combine these into one fraction with cosine in the denominator. And hopefully at this point you're starting to kind of see how this works. And you should recognize that this is that Pythagorean identity. Sine squared plus cosine squared is equal to 1. Okay, so that's going to be secant of t. Okay, looking at this technique that we have here, we are going to use common denominators in order to simplify these. So sometimes that's the technique that we need to work with. So if I'm looking at these two fractions and I want to get a common denominator, then I'm going to need to multiply this one by 1 plus sine, and I'm going to need to multiply this one by cosine. So I'm going to just recopy it here. Okay, So this one, like I said, in order to get the common denominator, it's going to need to be multiplied by 1 plus the sine of theta. And we'll multiply the top and the bottom by that. And then this one's going to need to be multiplied by cosine. So now they both have the same thing in the denominator. So I can combine them and start simplifying here. So this is going to be, I'm going to distribute here. Okay, so I'm going to have sine plus sine squared. And all that is over 1 plus sine theta cosine theta. Over here, I'm going to have cosine squared over 1 plus sine theta cosine theta. Okay, so I'm going to combine these together since my denominators are the same. So I'll have sine theta plus sine squared theta plus cosine squared theta. Okay, so now hopefully you see this and recognize it. So in the place of sine squared plus cosine squared, I can put 1 plus sine theta. Okay, so these two expressions here and here are equal to each other. So this is 1 over cosine of theta, and that's equal to secant theta. Okay, this example is going to be one where using bunny ears is going to be helpful. It is possible that if you wanted to go ahead and substitute for in the place of tangent sine over cosine, you could work this out that way. It's just the bunny ears is going to make it go a little bit quicker for us. So with the bunny ears, what we do is we take and put each part over the denominator. So we're going to have sine of t divided by tangent plus tangent over tangent. Okay, so here I can simplify this, and I'm going to have sine of t divided by sine t over cosine t. And then this, of course, is going to simplify to be just 1. Here I have a fraction, so my first fraction is sine of t, and it's being divided by this. So I'm going to do keep, change, and then flip. Okay, the signs are going to cancel, and so my simplified expression is going to be cosine plus 1. Okay, if we look at this one, we've got cosecant times cosine squared plus sine of x. This is one that I'm going to go ahead and start by substituting for cosecant of x. So in the place of cosecant of x, we're going to put 1 over sine of x times cosine squared of x plus sine of x. So this is going to simplify to be cosine squared x over sine of x plus sine of x. So we need to get a common denominator here. My common denominator is going to be sine. So that means that the numerator and denominator here is going to need to be multiplied by sine. Okay, that's going to allow us to combine these together. So hopefully you're starting to see where this one's heading. Okay, I can put everything over sine. So I'll have cosine squared plus sine squared. And here is that known trig identity. So in the place of cosine squared plus sine squared, I'm going to put 1. And 1 over the sine of x is going to be the cosecant of x for my answer. And again, remember, it's not just this. You should be able to follow the logic. Like I said, it's like you're proving that this is equal to this. You're not just giving an answer of this. You're showing me how that happens. So this, all of this part is important as the final answer. Okay, so what we've been doing so far is simplifying expressions. So you start with a complicated expression and you try to simplify it down to something less complicated. Now we're going to move into proving these trig identities, and it's a very similar process, except with these you start with one side. Usually better to start with the more complicated side, and then your goal is to transform it to the other side. So it's like you already know what the answer is. You just have to connect the beginning and the end with the part in the middle. So some of the things you'll do are these same techniques we've done before. You'll use known identities, convert signs to convert everything to sine and cosine, get a common denominator if you need to, use the bunny ears, use a conjugate if you need to, which we'll talk about, and use our even and odd properties, which we'll also talk about. Okay, so here, this is an example of an identity. Like we said before, identities are true for every value that you put in here. So if I want to show, basically we're going to be showing, so we need to show that this expression is equal to this expression. So I'm going to start with my more complicated one. And I'm going to manipulate this until I get it equal to this. Okay, so looking at this, if I was to be simplifying this expression, the first thing I would do is to replace this secant with 1 over cosine. Okay, so next I want to distribute this. So I'm going to have cosine over cosine minus cosine squared. Okay, from here I've got cosine over cosine is 1. And then we know from our Pythagorean identity that 1 minus cosine squared is sine squared. And that's what I needed to end up with. So all of these steps have to be shown. So if you're verifying or showing an identity, your answer is actually the steps itself. It's not even this. This is already given to us. It's the steps in between that you answer. So be sure that you're showing those. Okay, on this example here, we are going to be verifying this identity, and it's definitely more complicated than what we've been looking at in the past. So this is one that we're going to have to prove by introducing something extra to it, and that extra is going to be the conjugate. We've talked about conjugates at various times throughout the semester, so I want to use a conjugate in simplifying this. So we're going to start with our more complicated side, and we're going to try to make it equal to our less complicated side. Okay, so if I'm starting with this, and like I said, I'm going to use the conjugate. If you remember, the conjugate is going to be the same expression but with an opposite sign. So we're going to use the conjugate of this denominator. You can do the conjugate of the numerator sometimes, or the conjugate of the denominator. It just depends on which you need to do. In this case, it's going to be the denominator that you would have. You have to have a plus or minus here in order to do this conjugate. So the conjugate here would be 1 plus the sine of u. And I've got to also multiply the numerator by that as well. Okay, so here I'm going to have cosine of u times 1 plus sine of u. And then here I'm going to multiply this out. I'll have to FOIL it or use the box method. That's going to be 1, inner and outer cancel, and I'm going to have 1 minus sine squared of u. Okay, hopefully you recognize this as the Pythagorean identity. That's coming from the Pythagorean identity. So I'm going to have cosine of u times 1 plus sine of u. And this is going to be equal to cosine squared of u. Right, from here we have cosine and cosine squared. So we're going to cancel those. And I'm going to have 1 plus the sine of u over cosine u. And we're actually almost there. At this point, now we're going to do the bunny ears to split this up. So I'm going to have 1 over cosine of u plus sine of u over cosine of u. 1 over cosine is secant. Sine over cosine is tangent. And that's where we needed to end up. So sometimes the conjugate just gives us that little bit different form that we need to be able to manipulate it and get it where we're trying to get to, which is this end result here. Okay, on this one we're asked to verify the identity. It really doesn't matter which one we choose because one is just about as complicated as the other. So if we choose this side because we've got this denominator here, and we could do the conjugate on this side as well, so there's nothing that says we have to start with this one. So we've got, if we start with the sine of alpha is 1 plus the cosine of alpha. If we use the conjugate, that's going to be 1 minus cosine. We'll multiply the numerator and the denominator by the same thing. So we'll have sine alpha and then 1 minus cosine alpha over, this is going to be 1 minus cosine squared. And hopefully you recognize that to be sine squared. Here, these are going to cancel. And we're going to have 1 minus cosine of alpha over sine of alpha. And that's actually as far as they wanted us to go because we have shown that it equals this expression we started with here. So it doesn't matter which side you start with, you just have to show it equals the other side through a series of logical steps that make sense. So if you're trying to jump from this first step to like this step here, and it doesn't logically flow, then you haven't verified it. You haven't done what's necessary to prove that. So you need to include enough steps that you have a logical flow from one step to the next as to why something is happening that way. Okay, the last type here that we want to look at is using identities using even and odd properties. So with these, we've talked in the past about cosine and secant are the even functions. Will be cosine and secant, and the odd functions are going to be everything else, which would be sine and cosecant, tangent and cotangent. So those are the odd functions. The even functions, the negative basically disappears. The odd function, it comes out in front of the expression. So here, if I'm starting with this negative is going to go away. So this is just going to be cosine of x. This negative is going to come out in front. So here I'd have cosine plus sine, and that would prove what I needed to prove. It's not enough to go from this step directly to this step. You really need to show that this negative comes out here to join with this other negative. So I know it's tempting to not write this, but you need to show that that's the logical flow. Otherwise, you're basically just rewriting the problem. So you need to show what's happening there. Okay. All right, that takes us to the end of this section on trig identities. I know it can be overwhelming. I would say just really process this, try to understand each step along the way, become very familiar with your trig identities so that when they do show up in a problem, you recognize them and can immediately make the substitution that's necessary. So all of that's important, and I just practice, practice, practice. It's definitely a skill that takes developing. And even now, when I'm presented with one that I haven't seen before, I may not go in the right direction the first time with it. Sometimes I run into dead ends and have to start over myself. So don't feel like it's something that you have to know the first time you do it. Just keep practicing with it. If you have any questions or I can help you in any way, please don't hesitate to ask. And I'll see you next class for our very last lecture video.